I'm very pleased to welcome John Frizelle that will speak about OpenShift and the mobile platform.
Thank you. So a little bit about myself. My name is John Frizelle. I am the Chief Architect with Red Hat Mobile. I was previously with a company called Feed Henry, and we were acquired by Red Hat in October 2014. Been working with Feed Henry and in mobile technology since 2008, so quite a bit of background there. All of that time, apparently, if my t-shirt is to be believed, means I have mobile superpowers. Let's see if that's true today. You can find me on Twitter at JohnFrizz and on GitHub, github.com/JohnFrizz. So over the next 40 minutes, what I'm going to be talking to you about is using the Red Hat mobile platform to build some mobile solutions. And we're going to be looking at that in the context of pairing up Red Hat Mobile and OpenShift Online to deliver these solutions. So what we're looking at here is it's a little bit marketing oriented of an architecture diagram, but basically it tells us that this mobile platform gives developers a set of features and functionality for building mobile applications. So you have facilities like Git hosting, Node.js source code, user and identity management, analytics, hosted build farm. So that allows you to take your mobile source code and generate binaries automatically without having to install and run the tools locally. As well as that, as part of the platform, you have this MBaaS, Mobile Backend as a Service. And what that's for is for the mobile applications that are on your device. A mobile application on its own is not much good if it doesn't have some back-end connectivity, some systems to talk to. And the model that we promote is you have the mobile application talking to a single API server that acts as a gateway or a mediator, and then from there into back-end systems. And we look at that in quite a bit more detail over the next 40 minutes. We work on a premise of bring your own toolkit. So we're not prescriptive on how you develop your applications. If you're developing a native iOS app, you're obviously going to want and need to use Xcode for your local development. If you're developing Cordova hybrid apps, it's really up to yourself what editor you use. We do have a nice integration with JBDS. That would probably be the recommended editor, but you're free to use whatever you want. Sublime, Atom, IntelliJ, Vim, Emacs if you're inclined that way. I'm not here to judge. So basically, we make it as easy as possible for you to develop applications the way you want to. Try and stay out of the way and basically get involved where we can add value. The mobile platform is deployed as a hosted offering at the moment, so it's software as a service. You go to the URL, you sign up for an account, and you use the hosted service in conjunction with OpenShift Online. We are working to make it available as a on-premise solution as well, so something that can be self-installed, and that's been built on top of the next generation of OpenShift, OpenShift 3, using Docker and Kubernetes. So, some of the key concepts we're going to talk about today. The first one is MBaaS. As I said, that's the mobile backend as a service. It's that piece running in the cloud that your mobile app communicates with. In this case, we're going to be using OpenShift to provide our MBaaS. Another concept that we have that we'll be touching on is what we call an MBaaS service. And this is a reusable piece of functionality within our platform. All of the backend systems are developed in Node.js. And the MBaaS service, it's a reusable microservice for encapsulating a specific piece of functionality that you might want to use again and again in different mobile projects or solutions. So for example, a connect connector into a CMS system, or a connector into an order database, or connecting to external systems like Twilio or Google or Salesforce. Today we're going to be playing around with 3 MBaaS services, and we're going to be fronting them with an API server, and we have a little application that we're going to be using. When we talk mobile, we tend to talk in terms of mobile projects or mobility projects rather than mobile apps, because the app is just the front end of the system. It's the bit you see and feel and touch, but without those back-end layers, mobile apps are pretty dead. If they don't have any back-end systems to connect to, they're not going to do very much. So when we talk about a project, we talk about the mobile app, we talk about an API server in the middle, and we talk about these MBaaS services behind the API server for connecting into your back-end systems. So the demo app we're going to be playing around with today is an app that allows you to scan barcodes and look up data from a website called Search UPC. So we have a barcode scanner embedded in the application. You scan a barcode, it sends it to Search UPC, and it gets the data back. Search UPC exposes its data via, some of its information via a SOAP endpoint, and then the response that comes back inside the SOAP endpoint is CSV. Nice. And what we want to return is JSON. So within this microservice we have, we'll be receiving SOAP that's wrapped around CSV, and we'll be transforming it into JSON to send it back to the client application. There's also the ability within Search UPC to see the last 5 searches that anyone that has used their service has done. Now, that information is not available via their API. It's only available on their main web page. So we have a piece of functionality in here that loads the web page, loads it up in an in-memory browser in the cloud, injects jQuery, and then pulls out the recent searches, to be able to display them in the application. Now, the app has no idea what's going on here, because it's just talking to this guy who exposes a nice, clean REST API for the functionality it needs, and the nasty HTML scraping and SOAP parsing is all contained in that barcode microservice. So we have nice encapsulation. We have that service doing just 1 or 2 things and doing them quite well. The other thing Search UPC returns is a URL of an image representing the product you just scanned. And that's typically a link to something in Amazon, because let's face it, Amazon sell pretty much every product you can think of. So we also have this image microservice that will take the URL, reach out to wherever the URL is pointing to, get the data back, stream it back either as base64 or as binary, depending on what parameters you give it, and then cache it for, I think it's 10 seconds or 30 seconds, so that if a request for the same URL comes in again, it serves it back out of cache. And finally, we have a dummy order service. So this is just a very simple in-memory, it keeps a list of things that in the app you say, oh, I want to order one of them. But the nice thing here is it has an API exposed. So if we wanted to take this and hook it up to a real-world order processing system, we can just replace the order microservice with one that connects into an actual system, and so long as we keep the APIs the same, this part and this part never know that we've switched out our order service for something else. So it gives you real separation of concerns between the microservices, that guy in the middle that's doing the mediation, and the mobile app on device hasn't a clue what's going on. He's nice and simple and dumb as possible, because one of the things that you need to keep in mind with mobile is it's very different to deploying an update to a web application. Once people start downloading and installing your application, you can't force them to upgrade. So the more information you put in the client, the more likelihood there is that you'll end up with bugs in your code in the client, and you're having to try and push out updates. You can't force people to take the updates, and you end up with old buggy versions of your software on people's devices that you can't do anything about. So if you move as much of your logic as you can to these two tiers and keep this as a very simple, basically a UI rendering layer, then most of your heavy lifting and most of your logic is back here, meaning most of your bugs are back here, and you can patch and update and redeploy this because they're just hosted web services. So, excuse me, how this is represented in the actual platform is this screen here, and we'll be in and out of this screen quite a bit, but we can see the same layout that we looked at on the previous slide. You have the client, you have this Node API server in the middle acting as the mediator, and you have the 3 microservices over here that are doing all of the heavy lifting. Okay, so let's not do any more slides. Let's do some code. Okay, so we have a version of the platform deployed that's hooked up to OpenShift. You go to openshift.feedhenry.com, you click request an invite. Before you do that, you need to have an account on OpenShift Online. It's a free account, takes about 2 minutes to sign up for. Once you have your account on OpenShift Online, you come back here, you select request an invite, you put in your details, your OpenShift email address, and hit sign up. You'll get an email with an invite link, and then you'll be able to log into the system. Once you log into the system, you'll land on this page here. This is the main dashboard. So from here, we have kind of 8 main functional areas. A set of material and resources for getting started, so tutorials, guides, walkthroughs, videos, that kind of thing. Projects, which is where, as a developer, you would spend quite a bit of your time. This is where you lay out the architecture for your projects with what different types of clients you want. Are they native? Are they hybrid? Are they web applications? That Node.js API server in the middle, and your microservices on the right-hand side. You have reporting and analytics to get information on usage of your applications, how many installs, how many startups, how many API requests, that kind of thing. Here's where you create those mobile microservices, the back-end microservices. Link into documentation. Drag and drop apps is a set of functionality designed more for line of business users and developers. So that allows people using a drag and drop system to drag fields onto a form. So standard text fields and number fields, mobile specific things like location capture, image capture, signature capture. And then without writing a line of code, these line of business users click a button, generate a mobile application, and they can start replacing paper-based systems. It's pretty cool for non-technical people, but it's not something we're going to really look at very much here today. Then we have an administration section where you can configure various pieces, connectivity, security, teams, collaborations, that kind of thing. So let's start by taking a quick look in here, because a couple of things happen when you first sign into the system. The first thing that happens is when you log into the system, you're using your OpenShift credentials. So the first thing we do when we get the login request, we proxy that request to OpenShift and get them to verify your identity. Assuming that your username and password are correct, we now have an active session on your behalf. We use that to set up an SSH key pair and an OAuth token so that we can communicate with OpenShift on your behalf and deploy applications into OpenShift. So in here under MBaaS targets, we can see that it created a target for us using my OpenShift username against OpenShift Online. And it's set up 2 environments. So environments are there to allow you to have control of the life cycle of your development. Like, you don't write code and just bang it straight into production. Well, sometimes you do, but normally you go through a kind of a dev test cycle. So what we have here is a concept of environments. to allow you to deploy your Node.js code and build your applications in different environments and move your mobile solutions through a life cycle so that you can continue to iterate on your development in your dev area, and you're only deploying things that have been tested and verified to your production environment. You have the option here under environments, if you had a third stage or a fourth stage in your lifecycle flow, you can add additional environments and hook them up to one or more of these MBaaSes. Over in OpenShift, under the settings area, we can see the keys and the OAuth token, that was created to allow connectivity. Revoking these tokens would prevent our platform from being able to talk to OpenShift, and next time I try to do anything with OpenShift, it will pop up a message saying, we're no longer able to authenticate against OpenShift. Can you please put your username and password back in, and we'll recreate these tokens. So it self-heals if the tokens expire or if they're revoked for some reason. Okay, so back in projects, as I said, the application we're going to play with here is a barcode scanner application. And this is the screen that we saw in the final slide of the presentation. So we can see that we have a Cordova application here, Node.js API server, and 3 Node.js microservices. Within the client application, we have a set of details about the application, IDs, access keys, Git URLs. So all of the applications that you create are backed by a Git repository hosted within the platform. So straight away, it should start feeling like a fairly familiar workflow. You git clone, and you can start developing locally. Over here on the right-hand side, we have a preview of the application. Because it's a hybrid application, means it uses mainly web technologies. So we can preview it in the browser without actually having to install it on device. Obviously, this doesn't work for native iOS and native Android projects, but for the hybrid applications, the preview can be quite useful for just very quickly looking at the functionality. Going to just pop this out for a minute. As I said, it's not a particularly pretty app. I keep meaning to go back and do something with it and make it look less ugly, but there you go. So what we're seeing here is the list of 5 recent scans from Search UPC. Over on the Search UPC website, we can see the same list. If you click on one of the scans, it shows you your product details. So within the mobile application, we've implemented the same functionality. Now here's where this demo. Oh, sorry, got myself caught up. Here's where this can get a little bit interesting. I have no idea what other people have been searching for. So we've had a couple of occasions where we've clicked on something and it's been a little bit, shall we say, not suitable for work. So disclaimer, I don't know what's going to show up here. I am not responsible for what shows up here. So as we click on each of these, what's happening is this client application is making an API call to that Node.js guy in the middle, who in turn is mediating the call out to the barcode service to make that SOAP request and get the data back. It then pulls the image URL out and it makes a call to the image service to get a base64 version of the image back. We build all of that up as a JSON object and send the whole thing back. So we're getting everything we need back to the client in a single HTTP request. Along the way, we strip out any data that comes back from Search UPC that we don't want or need to keep the payload as small as possible going back into the client application. So let's see what we get. Organic oils, natural hair mask. Okay, that's not bad. A handsome dude. Oh no, sorry, it's the jacket, it's not the guy. Another dude with half a head. And a dude with no upper body. Okay, they weren't too bad. So let's look at actually getting this as an application on our devices and maybe have a little bit of fun with it. So we're just going to quickly run down through the functionality available on the left-hand side here. Documentation area that just allows you to provide information about the application, say for developers coming along behind you. What kind of frameworks it uses, maybe some structure of the code, just useful information. This is basically your README file. In fact, it is your README file in the root of your repo. So the kinds of information you'd normally put in a README file are the things that will show up here. There's a live editor, which is handy for making small, quick, like typo corrections or very minor modifications. You can open your various source code files and make changes and see those updates reflecting your preview. But this is not really intended for actually writing your application, because let's be honest, if you had to try and use a tiny web-based editor this size, you go crazy fairly quickly. So the majority of your development is going to be done locally, and we'll get onto that in a minute. We have some analytics information. There's not going to be a lot here because, yeah, the app hasn't been used in quite a while. Configuration section, integration of push notifications. We need to enable push with various keys and credentials. And then the fun part, building the application, getting an actual APK that we can install on device. So in the OpenShift Online version, Android is the only platform that we support through the build farm. In the full enterprise offering, it supports Android, iOS, and Windows Phone. So we're going to build off master. You can specify a branch, a tag, or a commit that you want to build from. We're going to build a debug application because in Android, they're really simple to build. You don't have to set up any keys. You don't have to do anything. You can literally just click build. And we're saying that we are talking to the Barcode cloud app. That's the guy in the middle. It is possible to have more than one of them, which is why there's an option here to select which one you want. So if you have an Android device, there will be a QR code appearing in just a minute if you want to install my lovely, ugly-looking app. So what's happening here at the moment is it's taking the source code, it's sending it across to a hosted Linux machine that has the Android build tools installed. Because this is a Cordova application, it's doing the Cordova bundling and packaging that's needed to add the Android platform to it. And then it's invoking the standard build tools, giving it all of that information, plus any credentials and certs that were sent across, generates an APK, and gives us back a link to it. This can take just a minute, so I will talk quite slowly while we wait for this to happen. Anyone know any good jokes? No? Okay. While we're waiting for that, a couple of other, it always does that to me. As soon as I go to move off, okay, there we go. If anyone does have a QR code reader, let me just make that a little bit bigger. So if anyone has a QR reader and they want to take a snap of that and install the application, I see a couple of phones out, so I'll just step out of the way for a minute. Okay, we can come back to that if people didn't get it. There's also a short link there, and you can download the APK directly onto your machine and install it over USB. Okay, so with the application installed, what do we get? We get a very sad-looking face. Okay, let's try that again. This worked perfectly earlier on. Sorry about this, folks. Sorry? Yeah, this is not going to work. Basically, I was just going to demonstrate real-time scanning an actual barcode and seeing the whole flow through. But live demos being what they are, that's not going to happen. Beg your pardon? I could try doing that.
Or you can use the HTML version, which is in the platform UI as well. There should be the link to work also in the browser. It doesn't look exactly like in mobile.
Yeah, okay, that's not going to work. Right, well, let's try that. No, the Cordova, actually, yeah. So the barcode scanning functionality is a Cordova plugin, which has a layer of native code for interacting with your camera on device and overlaying the barcode scanner piece, which means that it won't work in the browser because it doesn't have the native OS bit underneath.
A couple of weeks ago in Frankfurt it worked. So I was in preview in the studio.
This exact demo? Sorry? Yeah, I don't have Chrome remote debugging set up. Okay, it's not going to play ball. Let us move on because we're fast running out of time. Okay, I want to talk a little bit about local development. So we've had a bit of a look around the App Studio at the various bits and pieces of functionality. But in terms of actually building out these mobile solutions, as I said, you're not going to be doing it from the web browser. So we have a command line tool called FHC that I tried to update about an hour before the presentation. And it uninstalled the old version and then just failed. I think it was because of the internet, so I'm going to very quickly see if I can install it again. And basically what FHC does is it gives you I will try not to do that again. FHC. Woohoo. So basically what it does is it gives you a command line version of all of the functionality that is available through the graphical UI. So this is very useful for developers for kind of standard development flow. You don't want to be going back to a UI and clicking. It's a lot easier and quicker once you're familiar with the syntax of the commands to use the command line tool. It's written in Node.js itself. You may be sensing a theme here. We quite like Node.js. And what that also means is you can include it as a library and you can integrate it into a CI/CD process and automate nightly builds of mobile applications, deploys of your cloud code, automatically run tests on your mobile device. There's a lot of very powerful functionality that you can get to when you have the FHC command available as a library. So let's take a look at a couple of examples. So we want to see what projects we have. So we say FHC projects. And we get nothing. God, I love live demos. spelt it right, it would help. Okay. Okay, so we've basically, with the FHC target command, we've told it to target the same URL as we're using here for our web browser. I was already logged in, so it didn't prompt me to authenticate again. And then it gives us a list of our 3 projects in the same way as we can see a list of 3 projects here. We can then, if we want, get a list of the apps within the project. So we can see we have our client and our Node.js cloud code. We have a link to our Git URL, so we can git clone the applications and start local development. So I already have cloned the applications, and so the client application, the guy in the middle, and the 3 services, I have them all cloned and open in Atom here. So just want to quickly take a look at a little bit of the code that I was talking about earlier on. So the microservice for interacting with Search UPC is here. Can people see that font size okay? Do you want it bigger? A bit more? There we go. Okay. So this is the entire implementation of the get me a list of the recent barcodes. And what we're doing here, I'll try and stand up without ripping my microphone off. And I want to play with the stick, so. Okay, so we're making a HTTP request to searchupc.com, just a standard GET request. When we get the response body back, well, when we get the response, we check to see was there an error. I think the last time I did this presentation, I was working through this and it just would not work. Regardless of what I did, I thought I'd introduced a bug. I was trying and trying and trying. Eventually, I went to the Search UPC site and it was down, which is why I went to it so early this time to make sure it was working. So once we get a successful HTML response back, we use a node module called JS DOM, and we load in jQuery into the HTML response. The site doesn't have jQuery in it by default. We inject jQuery because the jQuery selectors are just so damn powerful. It makes it really easy. So having just viewed source of the web page, I could see that the 5 search results were in an element with an ID of current searches, and each one of them was a link. So a small little iterator to link over each of the children and pull out the actual URL of the link. And then we return that as a JSON object, and there we have a nice clean API, screen scraping in about 25 lines of code. Similarly for the read endpoint, in this case, we're using the SOAP endpoint. Sorry? Okay. So we're using another node module here called SOAP. We're creating a SOAP client. We are calling the get products function exposed from the WSDL. We get our response back. We pull out the product results, which is the bit that they send back as CSV, which is quite disgusting. We use yet another, oh, sorry, that was accidental. We use another node module called CSV to parse the CSV results and turn it into a JSON response and then send that back. So again, in 25 lines of code, we're integrating with a SOAP endpoint. We're pulling out a CSV response, transforming it to JSON, and sending back a nice, clean API. So similarly, then, the image stream service is even simpler. So all in, including boilerplate, it's 31 lines of code. Don't use it at all. Oh. So we get in a URL and a Boolean to say whether or not we want our image base64 encoded. If we do want the base64 encoded, we get the we make a request for the URL, we pipe it through a stream encoder and pipe it out the far side. And that's one of the really nice things about Node.js is its support for streaming. So you're not buffering large amounts of data in memory. You set up streams, you pipe things through as many different streams as you need for transformations, pipe it out the far side, and it's literally just the chunks that it has in memory at the moment as it's streaming it through. So it gives you a very nice small memory footprint. And all of that then is fronted by that cloud app that we talked about that exposes the set of APIs that we need as a barcode API and an orders API. For getting the barcode stuff, a little bit more involved here. We're caching the information for the recent searches for 10 seconds, so we're not hitting search UPC all of the time. So first thing we do is check to see if we have anything in the cache for the recent searches. If we do have anything in the cache, we return it straight away down here. If we don't have anything in the cache, we make a call out to the barcode service saying we want to call the recent endpoint, and we get our results back, stick it into the cache, and return it. For the read endpoint, similar idea. If it's in cache, we use it. If it's not in cache, we call the read endpoint. We get the information back from the search UPC site. We rip out the bits that we're not interested in to reduce the payload size. And we, somewhere here, I've lost it. Yeah, if we've been given an image URL, we call the image service and get it to stream the image back to us as base64, stick that into the response, and back it goes. So that's a pretty quick trot through the kind of high-level functionality of the platform and a little bit of a look at the implementation of some of the microservices that we use to achieve this functionality. I am 2 minutes out, so I'm going to throw it open to any questions if anyone has anything they'd like to ask. Yes?
Are you considering building native apps for Android, iOS?
Oh, we have support for native apps. So within the project here, you can add. So we have Cordova apps, we have web applications, we have native Android, we have native Android using the Gradle build system, native iOS, native Windows Phone. There should be native iOS using CocoaPods as well, and then some templates using some of the popular HTML frameworks like Ionic, Angular, and Backbone. So there's quite a selection of getting started templates that cover pretty much all of the bases.
Any plans to use the iOS build platform from a cloud service on the OpenShift?
It has been discussed quite a bit. I think probably ultimately yes, simply due to the number of times we've been asked that question. Doing the iOS one, sorry James, go ahead.
It's available to production customers.
Yep. Now I have two sticks. Okay, I think we're out of time. Just one final thing before I let you go. We do have a workshop on today in room A112 from 4:30 to 6:50. So if you're interested in learning a little bit more and actually having a play around with the system, Lukasz Fridge, one of my colleagues, will be running the workshop. I'll be there, and some of the other Red Hat Mobile folks will be there. So if you want to come have a chat with us or try out the system yourself, that is when and where you can do it. Thank you very much.
Sorry for the pointer, but we was allowed to use it before.
Right.
Now they changed
That's okay. I didn't know to not hit the screen though. Sorry about that.
No asi tu není jako.
That's always a fun feeling. Or do you want me to use the HDMI? I have an adapter. Can you tell me what's the better resolution? Same resolution? Okay. And VGA feels safer to me. You're probably going to have to turn down. Can you adjust the volume?
No kde je ta fleška, ale už nám odešel asi.
No. Because I have to use my hands. Just put it lower. Is that good?
Yeah, I think it's better.
Is it on? No, it's muted. Okay, so this is how loud. Yeah, see, it's very loud. Okay, so I'll try to talk a little quieter. And if it starts to hurt your ears, start making this. Yeah, exactly. Start doing that. Is it already like that? Do you already feel that way? Do I believe you? Should I believe you? What country are you from? This one? I know Marek. I don't trust you.